Okay, guys, so here we are starting our final journey. We got about three and a half months, let's say 4 months, until the AP Stats exam. And so now we got to focus on things that we haven't learned well quite yet, combine a few more new concepts, okay? And then we'll be prepared for the AP Stats exam. But anyways, let's get started here. So if we look at this problem 3 here, guys, we're given box plots. And remember, guys, whenever you're given box plots or any kind of graph, you do need to start annotating and breaking down the information. For example, notice that B here has a minimum value of 2, a maximum value of 8. So when they ask about ranges, the range is 6, right? Because 8 minus 2 is a 6. Whereas if we look at A here, notice the minimum value is 10, the maximum value is 16. Wait a minute, 16 minus 10 is also 6. So they both have the same range. Now notice the evilness or trick of the problem. They want to know which one's incorrect. That means, now most problems are going to ask you for the best correct answer, okay? But just know that if they ever ask you the incorrect answer, then basically you're just going to go through and find all the correct answers, cross them out, and then pick the worst of the remainder, okay? But anyways, we know that the ranges are the same. Guess what? That's true. We're going to cross it out. What about the interquartile ranges? Well, notice B, the Q1 right here is at 4, and the Q3 here. Okay, so guys, sorry I got interrupted, but that's okay. So we were talking about interquartile ranges. So notice with B here, it goes from 4 to 6. That's a distance of 2, a difference of 2. That's the interquartile range. The difference between Q3 minus your Q. It's your middle range of your middle 50% in essence, okay? Now, A, notice, goes from 12 to 14, which again is 2. So notice the interquartile ranges are the same as well. Now let's go to C. It says both sets are skewed both lower and higher values. Guys, if something is skewed both left and right, we call that symmetric. Okay? Now, let's talk about what we should know here. Notice on A, this is the ideal box plot. Why? See how the median is almost directly in the middle of my rectangular box. So that means the middle part is symmetric, right? Notice how this whisker may be a tiny bit shorter than that one. They almost look kind of the same. But the idea is the top 50 and the bottom 50%. Remember, this median here at around 13, right? I now know, according to that box plot, about 50% of the values are higher than 13, 50% are lower than 13, right? So, long story short, you ought to recognize that A is actually symmetric. Okay? What about B? Notice how the median is a little bit left of center in the rectangular box. What does that mean, guys? Is that the top 50% here, or more specifically the top 25%, if I just stay within the box, is more stretched out. See how it's more scrunched over here between, I guess maybe, I would say the median's around 4.5-ish. So notice from 4 to 4.5 is our lower middle 25%. Those data points are closer together, right? So long story short, guys, you ought to recognize when you have something that looks like this, it's more stretched out on the top end. Hence, it's more likely to be skewed right. If you saw something that looked like this, see how my median is right of center? That means it's more stretched out on the lower end. It's more likely to be skewed left. Okay? So skewed right, skewed left. Okay? And then just to totally convince yourself, include the whiskers. Notice if I start at the median, that bottom 50% is a little bit tighter and closer together than my top 50%, right? So any way you look at B, you should recognize it should be at least slightly skewed right, okay? But are both sets skewed both lower and higher? Generally, it'll say to the lower, that'd be skewed left, higher would be skewed right. No, they're not both. We know B is definitely skewed, only in one direction. So guys, I'm tempted to pick C, but guys, remember, always check your other choices. Answer D. Set A may not be symmetric. That's a tough one to swallow, guys. The median is maybe slightly right of center, right? So I still consider D incorrect, okay? A, you should recognize, let's say 95% of the time as basically approximately symmetric, okay? Let's look at choice E. Set A may have 100 times as many values as B. Now remember, guys, that this is like the biggest offense when it comes to box plots and histograms. Remember, especially box plots, guys, the only values I know truly directly from the box plot is the minimum and maximum values, okay? So in set B, I know my minimum is 2, I know my maximum is 8. But notice, guys, this edge of the rectangular box is telling me what percent at the 25% level it is, right? What values, how much is below or above the 25% level? The median is basically the 50% mark, where 50% is above and below that mark, right? Now, the median may actually show there, but as you guys know, sometimes the median can be in between the two middle numbers. And then this right here, Q3, again, is a 75% mark. So long story short, box plots gives us percentages, not the actual raw numbers when it comes to, in other words, they can't tell us our sample size or anything like that. Unless we actually are given the data itself to look at, we don't know with a box plot, bottom line. So, could set A have 100 times as many values as set B? Yes. Set A could have literally 1,000 pieces of data calculated in there, whereas set B could have only 100. Again, you don't know how many data points are in when you're just looking at the box plot. Hopefully you guys understand that. So, set A could be true. So, we're down to C or D, and guys, here's the bottom line. Our goal is to pick the worst of the two bad answers, because remember, we're trying to pick which one's incorrect. And bottom line, I would say C has to be the worst of the two, because D could be true or not true. More likely, it could be true, actually. So C is by far the one that's not borderline at all. We're going to go with that one. Okay, now guys, number 9. Both sets have the same mean. Guys, see how set A is like a mirror image of itself? Same thing with B, correct? They, of course, just switch the directions of the hump around, okay? But I hope you understand that because both of them are mirror image, we also call that symmetric, they potentially will have the same mean around 30. If I average all the data in here with all the data in here, they're going to average around 30. Same thing. If I average all the data in here with all the data in here, they're going to average around 30. What about the median? Well, the median, the middle number, remember, the median sometimes doesn't exist in the data. It could be between this number and this number here, for example, or this number and this number here, for example. Long story short, in this case, I hope you understand, the mean and median could have the same value. Notice the trick is we're trying to figure out which one's incorrect again. So I'm going to cross out A and B because they're most likely true. Okay, let's look at C. Do both sets have the same range? Well, notice set A starts at 10 and goes up to 50. Set B starts at 10 and goes up to 50. Yeah, Both of them look like they have a range. Remember, highest minus lowest, or max minus min. In this case, both of them could have a range of around 40. So we're now down to choice D or E. D says set A, excuse me, has a greater variance than set B. Okay? So, guys, hear me out. That potentially could be very true. Look at here, guys. Do you see how set A has more data around 10 and 50? Whereas set B has more data, if you look at it, closer to 30, around 25 and 35. Hence, remember variance, which is another, it's literally the square of standard deviation. Variance is standard deviation squared, literally, right? Well, what does standard deviation or variance tell us? How much the data is spread out from the mean. Well, set A has more data in the tails, let's say, on the extremes. So it should have a greater variance. Okay? But here again, guys, is something I need to remind you. E is the worst choice. Remember, we're trying to pick the worst choice here because they're talking about numbers again. Remember, when I'm looking at these histograms, guys, can you look at these histograms and tell me how big the sample size is? No. Set A here could have, both of these should have the same amount of data, but set A here, let's say, could have only a total of 20 data points. 10 of them here, 10 of them here. Likewise, set B could be the same. Of course, set B could be the other extreme. There could be in here 50 data points, just like here 50. Okay, the bottom line, when you look at a histogram, guys, you can never tell how many data points are actually in there. So that's why we're going to pick E. D is a bad answer because set A should have a greater variance, but E is the worst offense because remember, guys, this is the ultimate trick again with these graphs is they try to have you convert into raw numbers. Guys, when you look at a graph, a lot of times, especially histograms and box plots, you can't see the data itself, right? Or how much data is there. Okay? Hopefully you're starting to understand that. So E actually was the better, or I should say the worst of the two choices, which is what we want. Because we wanted which one was incorrect. Okay, 10. This one's really quick, guys. But again, it shows you how evil they are. Guys, notice, and this is the important thing, if you read it carefully, they're suspecting that the kids are doing more than 8 hours. In other words, our null hypothesis, guys, would be our mu is equal to 8 hours, and our alternative is going to be, no, our mu, we suspect, is more than 8 hours, right? These kids are just simply spending too much time playing their video games and stuff on their Xbox, Wiis, and PlayStations, okay? That's what we're suspecting. Notice they gave us, in our sample, a mean that happened to be close to 8, but also less than 8, right? They're trying to trick you. Here's the key thing, guys. Never do your hypothesis after you analyze or look at the sample results. Try to always ignore the sample results. The hypothesis has to be done, guys, before you do any analysis, before you do the experiment, before you just look at the data, period. So the trick is, guys, we were suspecting greater than 8 hours. That's what the correct choice is. They're trying to trick you to go less than 8 because our sample is saying less than 8. And notice they're even including the sample in those results. Guys, how can you make a hypothesis on the sample results when you're not even supposed to look at the sample yet? Right? So remember, hypotheses is always done before any crunching or analysis is done. Bottom line. So guys, hopefully you'll understand these three problems a little bit better. Study them really well, guys. We got to know those really serious thinking details behind these problems, okay? See you in class.